think we can go to the last presentation of this session. The title is Lesson Learned from Using Conversational Agents to support collaborative learning in massive online learning. The presenter is Santi Caballé from the Open University of Catalonia. Santi, welcome again. You can share your presentation and I go to the backstage.
Okay, can you see the screen? Yes? Yes, can you see the screen? Okay, thank you.
Yes, Santi, we can see the screen.
Sorry.
When we are in the backstage, we can't.
Oh, good. Let's see. Okay, so hello again to everyone. My name is Santi Caballé. I'm a professor of learning engineering affiliated with Faculty of Computer Science of the Open University of Catalonia, based in Barcelona, Spain. So this presentation is named Lessons Learned from Using Conversational Agents to Support Collaborative Learning in Massive Open Online Learning. And somehow I think it follows the previous presentation. So I think it will be a kind of a follow-up of two presentations of the same topic. Okay. So the results presented in this paper actually form part of a European project called COLMOOC that finished last year. It was participated by 9 partners from 5 European countries. The goal of the project was to enhance the massive online learning experience by integrating in MOOC platforms a number of discussion activities mediated by conversational agents in the discussion in chat-based discussions. So in the web page of the project, you can find detailed information and results of the project. The working methodology of the project follows this 4-step loop approach that you can see the slide, where educational approaches and technical components for the input of the evaluation stage of the conversational agent are integrated in MOOC platforms. So this
Santi, sorry if I interrupt you. We see we don't see the presentation view of PowerPoint. We see can you use the presentation view? So put the presentation in full screen.
I'm not sure what the problem is. So you cannot see the
full screen. We see the PowerPoint interface.
I'm sorry, because what I should do to do that? Do you know?
You have 2 monitors, 2 screen. No.
Yeah. Yes. That's why. Okay. Maybe now. Let's see. Let's try. Okay. It's okay now?
No, it's the same. It's the same.
Yes.
Okay. It's the same. We see the PowerPoint interface, but anyway, we see the
now
the slide.
Now it's okay.
We see
No.
We see the PowerPoint user interface.
I'm sorry for that. I don't know what.
Okay. No, don't worry. Go ahead.
Let me check this here. I don't know how to fix this. I'm sorry. Can you read the slides at least?
Yes, we can read. We can read the slide. Maybe if you. No, okay, we can read.
Yes. Okay. Well, I'm sorry for that. So let's follow the next one. So that is the agenda for this presentation. I will provide first some background on conversational agents to support massive collaborative learning. I will then introduce the COLMOOC platform as a key technology developed in the project, which supports the research presented here. And after that, I will move on to the research evaluation, which is the core of the paper. And I will present the evaluation methodology and the results of the pilot experience that we conducted within the project, as well as the lessons we learned during the evaluation. I will finish the presentation with the main conclusions.
Santi, sorry to interrupt you again, but we see still the slide number 2. Okay. Okay, we are on slide number 4.
Yeah, let me exit the presentation and upload again. Maybe we fix something. I don't know. Good. So, yeah, I'm here in the background. Try to be fast now to because to keep the time. So in this background, well, actually, recent approaches of conversational agents for collaborative learning take over the role of human teachers and provide real-time automatic pedagogical actions. This way, agents can provide individual and group scaffolding, for example, pedagogical support for collaborative learning, and also agents can promote opportunities to develop collaborative and social skills. A main representative of these approaches is mentor chat that you can see here in the slide, which provides many of the benefits we expect from a conversational agent in context of massive collaborative learning. When I say benefits, I mean benefits like promoting teaching involvement, stimulate the students' motivation and engagement, foster deep learning, which overall result in improving a student's performance while reducing dropout rates. So mentor chat became the basis of our approach as it was developed by the same partners of the COMO project. Okay, so next slide now. The technology supporting this research was entirely developed in the COMO project. This is why we call this technology the COMO platform, which has two main components or tools. The first one is the COMO editor, which is used by the instructional designers to develop discussion chat-based activities in MOOCs. And the second tool is the COMO player, which is used by the students to participate in the chat-based activities designed with the editor. Actually, this technical view is completed by the MOOC platform, where the COMO platform is integrated, and they both platforms communicate with each other by AP calls. So next slide. Hope you can see. So going more in detail, the COMO editor sets up the domain model represented by concepts, which are related to the task. The task, I mean, the discussion chat-based activities, and also linking verbs that associate the concepts. When two concepts are linked, they form what we call a conceptual link. There are different types of conceptual links according to the purpose. For example, elaborate on previous knowledge, verify acquired knowledge, suggestions, ask for explanations, etc. Then, when the agent identifies a pattern during the chat activity, the discussion, that matches the concepts or the conceptual links, then the agent triggers a predefined question about the concept to the students. This way, the agent asks relevant questions in terms of the topic of the discussion, and also asks the questions at the appropriate moment of the discussion. So next slide. Here there is an example. Actually, it's an animated example, but it's preferred to keep it static, not to complicate things. So that is an example where first the teacher uses the editor to insert a relevant concept related to the chat topic. Then the teacher adapts the question to be conveyed by the agent when the concept is detected. So the teacher is formulating the exact question. And finally, eventually, when a pattern matches the concept during the chat, the question is shown to the student in the player. Okay, so next slide. Now let's move on to the evaluation. The evaluation goals were to be achieved through conducting pilots in real MOOC scenarios. The main goals were to increase students' engagement and motivation in conditions of productive dialogue supported by the agent-mediated activities in a real MOOC. The specific pilot goals were to evaluate the effects of the agent-mediated activities in students' participation, performance, and satisfaction, as well as the connection with potential learning benefits of the MOOC and at the agent-mediated activities level. Okay. So, next slide. So, in terms of evaluation procedure, last year we ran an extensive pilot in the form of a MOOC course on the Myriadex platform, which is the largest Spanish-speaking MOOC platform in the world with more than 6 million active users. The MOOC we ran was about educational technology to support collaboration and evaluation in online education, which was actually highly appreciated by the educational community during the pandemic, when many educators had to move their teaching online and needing training in this process. So the pilot consisted actually in 2 editions of the same MOOC for 5 weeks each, with an overall participation of 1,800 people. Most of them were in-service or pre-service teachers. Apart from the traditional video materials and assessment activities usually found in any MOOC, we incorporated 5 agent-mediated chat-based activities supported by our whole MOOC platform, where students discussed in pairs, 2 students, on a topic for 20-30 minutes, and they were supported by an agent designed to engage them in the discussion. After each week of the MOOC, and also at the end of the course, we send research surveys to the students to collect feedback about their experience. So next slide. There were actually 2 different surveys sent to the students to collect qualitative information. One survey to collect feedback on the MOOC course in terms of efforts devoted to study the modules and satisfaction to complete the course material. And another survey collected feedback specifically on the agent-mediated activities as for the knowledge acquired during these activities. For example, whether the agent interventions were adequate in terms of content and time, and also the overall satisfaction with this type of activities. Further evaluation instruments included logs and databases to collect quantitative data during the pilots to be analyzed later on. Okay. Next slide. The evaluation results at the MOOC level show relevant participation and completion rate up to 25%, which is higher than the usual completion rate found in this type of MOOCs, which is from 5–15%. Performance in each edition of the MOOC was also quite high, as we calculated the difference between the summative scores in the final tests and the scores of the diagnostic tests issued at the beginning of the course. Interestingly, we also observed a strong correlation between participation in the agent-mediated activities and MOOC performance, since those students who decided to participate in the CA activities always obtain better scores than those who decided not to participate in these activities, as you can see here in a graphical form. Okay. So on the next slide, evaluation results at the agent-mediated activities level. More than 600 chat-based discussions were mediated by agents, which is an interesting result from a pedagogical perspective, as this means that hundreds of students had the chance to build their knowledge in a collaborative way with another student. In addition, based on the good results obtained on satisfaction and the benefits for learning, the agent mediation in these collaborative activities contributed positively to the knowledge building of the students. So from this large pilot experience, we actually learned a lot and had the opportunity to implement and test some improvements in the next trials of the same pilot, which after evaluation, we turn some of the improvements into good practices that we would like to share with the educational community. So now I will list some of the main lessons learned and good practices. You can find the complete list in the paper. So first of all, it is, in our opinion, crucial to plan, design, and test the agent-mediated activities much in advance the actual activity starts. This is actually common sense, but we understood that we need to plan much in advance, not actually 1 week before, but maybe 1 or 2 months ago before. This is a fundamental feature to address many pedagogical and technical issues that arise when designing and editing these activities mediated by agents. Also, it's important to estimate the duration of the activity and inform the students accordingly. The duration should not be too short in order to give time the agent to intervene, but also not too long for the students to keep engaged till the end of the activity. So another advice is that agent-mediated activities should have open goals to foster discussion, thus avoiding those discussions starting with questions with unit responses that may kill the discussion from the beginning. Also, it's important to align the agent design with the content of the MOOC by the agent interventions using the same terms of the course material so that the students feel familiar with those terms during the discussion, during the activity. Also, use a rather extensive, large list of the conceptual links in order to guide the students throughout the discussion by appropriate interventions, even though it may sometimes interrupt the discussion flow too much. In order to avoid this, an alternative is to silence the agent between interventions and also avoid overusing the same concepts. Okay. So next. Yeah. So finally, another relevant issue that we found was the group formation of the two students to get engaged in the discussion in the chat. Despite the large scale of the MOOC with hundreds of potential students to participate in the agent-mediated activities, it was actually hard for them to find a partner at the same time because students were participating in the MOOC across different time zones and facing different habits and also different cultural aspects that were difficult for them to meet at the same time. So the best approach we found was to suggest to students showing their preferred time slots to meet, even though some students still experience difficulties to find a peer to participate. This issue is actually the main motivation to reconsider whether synchronous activities like chat-based discussions fit well in the context of massive online collaborative learning. While these activities provide a unique benefit for learning, we believe they should be combined with asynchronous activities like discussion forums to give opportunities to all and meet the different students' personal needs in terms of participation time. Okay, and now to conclude, well, we found high levels of satisfaction with the agent-mediated activities and with a MOOC course. Agent interventions were useful to reflect on the domain concepts, and also they created opportunities for active learning and dynamic discussions. From the evaluation, we observed low dropout rate and increased performance. Some negative remarks that we received were the difficulty to find a partner to start an agent-mediated activity at the same time, and the agent intrusiveness, which sometimes interrupted the discussion flow too much. So a summary of the good practices for next similar experiences are to plan, design, and test much in advance, allow open and multiple responses to foster peer discussion, and propose a few preferred slots is a reasonable approach for students to find time at the same time to meet. And the final recommendation is to combine synchronous and asynchronous collaborative learning activities to meet everyone's needs in the context of MOOCs and large-scale online learning in general. So that's all. Thank you very much, and apologize again for the problems to show the slides. If you have any questions.
Okay. There is any question from the audience? I have a question, a curiosity about the decision you take of supporting peer discussion. So why you decided to divide the students in pairs, not in groups, or to support a conversation with many students together, just two.
You mean why two students and not 3 or 4? No, you mean, or more?
Yes.
In that. No, actually, here the feature, the key feature pertaining to this collaborative learning model is synchronous or asynchronous. I don't think that 2, 3, or 4 makes the difference. We made this decision from the beginning in order to organize the groups. Otherwise, it's difficult to design, to predefine collaborative activities that the target is we don't know how many students will join the discussion, and also because we had to organize the groups, and we prefer to keep this let's say a strict way that for peers to meet. That actually is also from the literature, that is a specific way to build knowledge from two students and a third party like the agent or human teacher that is supporting the discussion. So that came from the decision that we made from the beginning, and we decided to keep this way in order to have the correct support from the technology and also from the methodology and the research perspective. But again, I think the key feature here is the synchronous or asynchronous.
Yeah.
Okay, so that's why this final recommendation, that from our experience, we learned that in this context of large-scale collaborative learning, it's important to keep some opportunities for asynchronous collaborative learning, because many students missed actually our activities because the difficulty to meet at the same time.
Okay, just another question that reflects a question to the previous speaker. Maybe I already know the answer, but I ask to you if you plan to improve the agent, the conversational agent, to include more advanced conversational capabilities based on AI rather than on rule-based system.
Yes. Yeah, the answer is yes. That project was thought to develop this conversational agent based on rules. That was also a decision that we made from the beginning. You know how projects run, and that was part of the proposal. So we kept our promise to develop this way. For the next project, which is a continuation of this one, we plan to develop the more advanced conversational agents that are trained using AI systems that not only support collaborative learning, but also are able to make recommendations based on the profile and the progress of the students during the course. So yeah, the answer is yes. We plan to use more advanced technology and move from rule-based that, well, some people have doubts whether it is artificial intelligence or not, and developed a real artificial intelligence based system to support the students. Yeah.
Okay, I don't see any more questions, so we are perfectly on time. I just suggest you to also attend the second session of the Alice track that will be held tomorrow, same time, 10:30. Okay, see you tomorrow. Thank you.
Thank you, Nicola. Thank you, everyone.
Thank you. Bye.
See you tomorrow.